Hello, Cardstack community. This is Chrissy and Hassan here from New York City at the new Cardstack studio, which, as you can see behind us, is totally empty. Hopefully not be much further, but this is kind of our first week here. It's pretty exciting. And we want to give you an update of a lot of work that we've been doing. We've been doing that stuff with a team that's around the world, in here, Boston, in California, and in Europe. So we're excited to show you not only a little demo of what the code that you can play with, and we'll open source it, but also walk you through a little bit of our thinking about how this is kind of a call it an MVP, or minimal viable integration of all the different pieces of the Cardstack components into something that resembles an application. But obviously, as we do this stuff, our goal is to fulfill the vision and kind of find a narrow path to integrate top to bottom. And our vision is to build essentially the platform for Web 3.0. So for those of you who have been in the Cardstack community, you know that we define Web 3.0 slightly differently than other people who define Web 3, like just the Ethereum community, or the community talking about what happens after Facebook, or these kind of web stuff. So I'm gonna do a quick recap of like what we're aiming to do, and then we're gonna jump into what we have built and what we'll show you. And Hassan will walk you through a demo and do something with the Trezor wallet and everything else. So in our opinion, Web 1.0, which is when web pages link together in a true web and hyperlink and surfing the web, is very exciting. There's a lot of opportunity for serendipity and new things. Every web page looks a little bit different, and it's very easy to learn to be a web developer and build something. And what ended up happening is that as web grew up to this Web 2.0, or these social networks, or these kind of communities and collaboration, the website got bigger, but it also became more of a hub model where every content, all the people congregate around one or two websites. Some of the websites are called Facebook, some are run by Google, and Amazon apparently owns a lot more than you think, even though they don't put the word Amazon everywhere else. And that's Web 2.0 era, digital superpower, really winning over the consumers, but now creating a situation where this hub and spoke model caused a lot of problems. This is a centralization problem that I think a lot of people in crypto and blockchain trying to solve. And the question is now, if we increment the version number to 3.0 and bump it, what does it really mean for everybody, right? And for us, and we have covered this in the November update, is that we see Web 3.0 is really combining fourth aspects of things that's concurrently coming on into the world in terms of the next iteration of the web. So bringing some of the diversity of Web 1.0, different websites and different styles, with the connectivity of Web 2.0. And we can do that, and there's a good design patterns and product ideas that we're incorporating here. But I think to make that happen, we also have to think about Web Dev 2.0, the development structure of moving away from server-side programming languages to JavaScript and API in particular, because that runs both on your browser and sometimes on the server. And that gives you a lot of flexibility to integrate data, to integrate APIs in a cohesive way, regardless of whether doing it in what is traditionally known as client in the browser or on the server. We leverage a lot of that Web Dev 3.0 technique in the Cardstack stack. And Web 3D, this idea of game, is really something that is most exciting, I think, to me, is that some of the most innovative and some of the most engaged community on the internet that's actually happening within Fortnite, within these games, and people exchanging objects, people kind of building up credentials and having economy and trading. And those ideas are not really in the websites that exist, and certainly not in the Web 1.0, the more kind of hyperlinked version, more like the centralized version of that on the web. And then finally, I think crypto, the Web 3, especially in Ethereum, brings us the value exchange that allows these concepts to come together in a way that allows fees to be paid, people to be compensated, and people do valuable things to get rewarded. All of these ideas, these four ideas, web, app, game, and crypto inspire, I think combines to be the substrate of what it is to form this Web 3.0 idea. But what's been missing is, beyond just the qualities of, the web is linkable, inclusive, referenceable, the app is functional, focused, empowering, you can do a lot of stuff. Games are tangible, you can interact and you can put things in spaces. And cryptos is verifiable, transferable, and synchronized. All these qualities that we have worked really hard to incorporate within the Cardstack framework. It's what is the thing that the user sees? What is a tangible object that people can interact with? And for those who have been keeping track of card UI as a kind of practice that's been going out there, we believe these things become essentially individual objects that you can store, exchange, and create. Whether it's content, data, assets, actions, messages, or stuff like that, there's like a shape around them. Now, these cards actually turns out to be something that people are quite familiar with. So the app is, you know, the thing that contains. The card is usually a piece of object within an application, in this case a mobile form factor, that if you stack a bunch of them together or you swipe left or right, you compose your experience, you compose your network and create different infrastructure. So we believe these are going to be written in HTML and JavaScript, which allows us to be much easily incorporated, so my card can be in your app and your app can become a card and be brought in my app. So those are very exciting possibilities. So, to explain in a tangible and concrete way what cards can be, we decided to build an application that showcases cards. So in our case, card is a representation of data in the ecosystem. What better data in the crypto ecosystem than to represent some cryptocurrency, some Bitcoin. Our demo's in Ethereum, but you can certainly use our stack to support other things. So we've been using a crypto portfolio tracker as a way to show how, you know, you can represent an address, something that you possess the private key for, and say, hey, this is something I possess the same way a boarding pass or credit card is something that has that shape. But what's great about card is that this can be inside another card called wallet, and that wallet includes multiple addresses of different types. And these are active assets that you might have in the Bitcoin network and other type of fork networks and privacy coins network, and they can be organized and summarized. But what's interesting about it is that each of the card can then zoom out and give you low-level context. So in our particular scenario, we try to say, okay, what do you need other than on-chain information? You need to have exchange rates, which come from API, and you need to know which address in your wallet, which come from another API or data source. And we'll show you most of that later on. Hassan will walk you through that. So there's an integration of different data that exists on the cloud, on your own personal either device or own personal data repository, and from the blockchain, and marrying those information together. You might even in the future tag it to additional annotation that's particularly meaningful to you. So that becomes something that you can zoom in, but you can also zoom out. You can just say, hey, let me organize all my information, not worrying about whether it's in a wallet, in someone else's custody, or it's in my own Trezor wallet, or it's something that is in an exchange, right? We can summarize your asset across that. And that mobility of cards really provide that basic idea that these things are tactile, more like in-game object. I give it to you, you can stack them and organize them in your trophy room within your game. And this tactileness of card requires a slightly different programming model, and we'll get to that in a second. So we believe that this whole idea of embedding really requires us to rethink what an app really is. Not only is a card requires you need to have the template and the logic in JavaScript and the data model, they need to also figure out relationship delegation method access, in this case, permissions and constraints and schemas and mapping to different data sources. This becomes the definition of what I have finished making a card. You have to do all these things, have that in the GitHub repository, and we have made a lot of that, and some of them will be shown in the demo today. And then, you know, a lot of the layers of the blockchain, when people do layer 2, layer 1, they're around this coordination consensus running on infrastructure on the cloud, on the desktop. What's been missing is, if you want all these applications to be truly useful, you need to have this user experience, and how do you synthesize that data together? And that's really where the Cardstack application framework is trying to do, is to provide not only the basic framework to go build this, but also sample application that you can compose it together. So that when the data comes from either your computer or on the full node, on the cloud, on a Geth node, it gets synthesized into a data synthesis workflow indexing engine that is part of the Cardstack framework, and that also very nicely composed into new objects that represent something that is real to you, not just a bunch of hashes that's in the block explorer, or something that's closer to your perception of the world, and then this stuff actually synthesized into a card in your experience. Okay, so we're going to show you an example of a real working app that has all these things working across running the infrastructure, synthesizing the data, tapping to the consensus of the node itself, and obviously the UI component that you see. So we call this demo app Card Folio, and this will be open source very shortly. It's kind of a combination of a blockchain explorer, a portfolio tracker, and wallet. And those definitions don't really matter. These are things that they will be familiar with you once you see them. The use case is not really the key here. The key is to show how we can take what used to be a very different blockchain explorer is one company, Etherscan, and portfolio tracker is another company like Blockfolio on the iOS, and then wallet app is a mix of those things. We can say, no, that doesn't really matter what the definition of these category of software is. What matters is that there's a user, a card. That user has a portfolio. That portfolio contains multiple addresses and type of wallets. The wallet either is derived from a private key or it's such a list of addresses you're interested in. Those wallet contains assets, in this case, a lot of time addresses, and it could also be an item within a ledger in an ERC20 kind of way. And that asset is led to transaction. And these things connect together to give you that user experience. And that experience is compositional from these basic units. And if you look at this as Cardfolio has this 5 type of cards, and then using that as a way to understand what we're dealing with Cardstack, is that each layer of the Cardstack architecture is powering a basic piece of infrastructure that allows a particular card to exist. So if I want to know the transactional detail of an Ethereum transaction, what the gas fee is, did it succeed, and stuff like that, I need an Ethereum plugin to go and look at in the full node and or even like a Explorer as an API and get that information in there. Then you can imagine that with transactions, once you have, getting enough transactions together, then you can show a balance. In the Ethereum balance, a BTC balance, slightly different in the way you calculate it. But now you say, okay, I have that many ETH. And that's a summary of those individual transactions. And then on top of that, you can also see that expand. So instead of just writing Ethereum plugin, looking at a raw Ethereum data, you can start looking at inspecting and introspecting the smart contract and looking at your the balance of the ERC20. This is something we shipped when we did the token generation event. We have a wallet feature that looks into the card balance that you have, and that's a plugin that currently is existing in our repository. And then you can get more specific about different smart contract plugin, and those things will be reflected in the EVM token, like the card token, and certainly non-fungible token like CryptoKitties will be built there. So those are just assets. I have some CryptoKitty asset, I have some ERC20 token, I have some ETH, and I have some Bitcoin and Bitcoin forks. Now, you can certainly imagine that in a e-banking system, if we look at this as DSR and finance, people can build e-banking and say, hey, what's my USD balance? I put some away here that you can also use the transaction and asset card, a lot of the UI for it, and tap just by using a different Cardstack data source plugin to bring that information. So they all just look like assets and transactions to you. And then now you know these assets existing and say, okay, I want to keep track of all these assets. Here's a list of addresses and where they come from, what network they come from. Or you can actually say, hey, let me scrape your Trezor wallet, and there's something we haven't built yet, but we'll do soon, and find all the addresses that you care about. And then we can then use those addresses to go look for the asset, and the asset would then look for the transaction and synthesize that data. That's how we give you a portfolio. And that's one thing about the portfolio is that we would need something like an exchange rate. And that's what this thing is right here, which is that we would then take the history and when that transaction happened, when do you get the ETH in, when you get the ERC20 out, and correlate to some price feed and cache it nicely and tell you what your portfolio value, your buy in, buy out, your airdrop, what's the actual value of it. And that's all kind of compositional and synthesized on the top. And then the user at the end of the day would now log in to this system, assuming this running in the cloud, which is what we're doing now. But you can certainly run all of Cardstack on your own computer so that your entire watch list, the addresses and what you care about are not leaked to anybody. Nobody knows that these addresses or these assets are correlated. So it depends on whether you take a more convenient approach or you want to run yourself. So this is pretty cool. And then you can imagine in the future, if we are doing it with e-banking, that same portfolio user may be mapping to something that exists. You have an existing account with a financial institution. I've spoken to a couple really big ones, international organization in the last 2 or 3 weeks. They have customer profile through single sign-on in the existing databases. You can use the portfolio and user guide to tap in those data sources and reuse essentially the same Cardfolio set of 5 cards as your user experience, even though you're kind of going into enterprise system to retrieve some sort of secure data. So this is kind of how the Cardstack plugins that would exist in our GitHub repository will be synthesized. And this green stuff, the Ethereum plugin reflecting your ETH access, having a watch list in Git, getting a portfolio that is mapped to exchange rates that allows you to log in to see the information is what we ship, and that's what we're going to demo to you right now. So the demo UX contains the green stuff, and then we'll come back and talk a little bit about what's in development, what's planned work, and what is kind of next, using this as a way to expand the scope of not just Folio as a product, but also Cardstack as a framework for building decentralized financial application. So with that, I'm going to pass it to Hassan.
Hi, everyone. My name is Hassan. I am a developer here at Cardstack. And so Chris's challenge to us was to create an interesting novel app using the Cardstack plugin. And so I'm going to show you some of those features today. So first here, let me just log in. Okay, so as you saw from, so this is a live app that's running in our staging environment. And so as Chris was explaining, there's a lot of different aggregations of data. So at the highest level, what we're looking at here is a portfolio. A portfolio contains wallets. A wallet contains assets. These assets happen to be addresses on various crypto networks. And so what you're looking at here is my sample portfolio. And one of the neat things that we see here is that the values from the individual assets are being rolled up to the highest level. But you see the various sums at each of the different levels. So here you see, okay, well, this is Ethereum address, and this is the current value in US dollars for today, as well as one for Bitcoin, Litecoin, Zcash. And so we're actually pulling all these conversion rates for these various cryptocurrencies into US dollars live. And this is all coming from Crypto Compare. And so we roll that up into the overall value for the wallet itself, as well as for the portfolio. We only have one sample wallet in this particular portfolio, so it looks the same. We can also slice and dice this information. And so what we're looking at now is the wallet, but we can actually separate this out here and look at the individual currencies. And so we see all the Bitcoin assets, the Ethereum assets, the Litecoin assets, and as well as we're deriving the USD value, and then we're summing that up for each different class of cryptocurrency, and then rolling that up. So you get this nice view here. And the real power of this is actually all happening from our server-side compute, which we'll talk about in a little bit. But that's allowing us to do all the heavy lifting in terms of like doing correlations between different data sources and perform that work on the server so that the client has all the baked information all ready to go, and it can just literally worry about how to render that on the screen and not have to worry about like, oh, I have to sum up these particular currencies or these particular wallets. All the information is already done for the client. Let's dive in a little bit deeper. So let's take a look at this particular card. And so this is an Ethereum asset. And so one of the things you'll notice here is that, and Chris showed this a little bit, but when I switch back and forth between this card, what you're seeing is this embedded view and isolated view of the card. When a card lives within another card, which is what you see here, it's said to be embedded into another card. We can then isolate that embedded card, and that card now takes up the full screen. And so that's what you're seeing here. So I'm going from an embedded view of a card to an isolated view of the card. So in this particular card, we're showing you an Ethereum asset. And so this particular Ethereum asset, what we're actually showing you is the value of that particular asset over time at the exchange rate for that particular day. And so what we're actually using is Crypto Compare has it's called the weighted, I believe it's the weighted volume average daily rate. And so that's what we're actually showing you here. And then, so what that means is that on midnight at GMT, we actually take the value of the asset and we create a data point for that asset. So we see that asset fluctuate, as well as when transactions occur, we also plot those as well. And you'll see the transaction value at the time that the transaction occurred. And so that's what you're looking at right here. And so one of the neat things that we can do here is we actually keep track of we keep track of these asset values in different currencies. So this is a USD currency. Now we're looking at the euro currency, or as well as we can actually look at this in terms of BTC. And when we do that, we actually are changing like the whole site. So now I can see the whole site in terms of BTC. So if I want to like take a look and see like how everything is sliced and diced in terms of BTC, you can actually do that. As well as we're just using a really standard charting library here. This is called High Charts, and specifically this is a stock chart offering that High Charts has. So it has like just really simple things that allow you to like zoom in, zoom out, take a look at various different ranges in terms of dates. Additionally, for each particular transaction, we see transaction embedded cards. So these are embedded cards for transactions. And I can click on a particular transaction, and that will isolate that embedded transaction card. And now I'm actually looking at the isolated transaction card. Going back to this card, this is actually pulling live data, so I can actually perform an Ethereum transaction. Well, let's do that right now. We can actually see it happen live. So I happen to have my Trezor wallet here. So let's just send some ETH to this particular address. So I'm just going to send it to here, and I'll send. We'll do 5 ETH. I'll just confirm that. Okay, and now that transaction is currently being mined, and we should see that once that transaction is mined, we have a Geth node that we're actually using as one of our data sources. It's our Ethereum plugin. It's using a Geth node, and it's actually listening for new blocks. And as blocks are mined, it's actually looking to see if a transaction, oh, and there you see it right there. It's looking to see if there is a transaction that occurs that is the particular address that we're tracking right here. And if it detects one of those, it then fires an event, oh, we have a new transaction, and then basically the Cardstack Hub does its thing. And so what it's doing is it's then indexes that particular data source with that new address that has a transaction. And then what that does is that triggers all sorts of invalidations to occur within our index. When invalidations occur, then we recompute our server-side computed. So we have an asset history server-side computed that is actually correlating the address value, the transactions for that address, as well as various crypto compare rate for today, and then putting that together to create a time series of all the different data points for that asset's value over time. And so that's what you're actually seeing here. We can actually even scroll down a little bit, and we can see this is the new transaction. And this looks really similar to the kind of thing you'd see on Etherscan. And really what we're doing is we're just pulling all the same information that Etherscan pulls. We're just displaying it in a slightly different way, but it's all there. And so that's pretty much what that looks like. So I did want to step back and talk a little bit more about what our data sources are comprised of. So I've mentioned that we have a bunch of different data sources. We have a Git data source that we're using for our user-provided data. So our user-provided data in this case are the actual assets that we're interested in, or their particular addresses, the wallet, and all the various addresses that are contained within the wallet, and then the portfolio itself, which is the aggregation of all those wallets. So we are actually using a Git data source. We could have chosen many different data sources, but we thought Git was really interesting in this particular case, especially for developers. Developers are very familiar with Git, and they also know that Git can version or keep versions of things in a much more sophisticated way than you could do with just about any other data source. It is the most sophisticated way to keep version data sources. And you can imagine, like, if you want to track, say, like, content and people contributing to content, Git's an awesome way of doing that because code is a type of content, right? So anyways, we're actually using Git as our data source. So as users save information, it is saved into Git. And then what we can actually look at, right, what we're looking at here is the portfolio itself. So this is the portfolio that we were looking at. And we can see that this particular portfolio actually contains a wallet. And it's also associated to a user too. And in this manner, only I can see my portfolio. No one else can see my portfolio. And so we have this wallet. It's called Demo Wallet. Not super interesting name. And so we take a look at our demo wallet data structure. I do want to take a little side note. The structure that we're actually using is called JSON API. JSON API is a very fascinating format for data and for expressing relationships. It's been around for, I think, maybe 5 years now. And if you use Ember, it's built into Ember so that it is the simplest data structure to use. And we just find it's very robust in terms of being able to represent relationships, as you can see right here. So in this particular wallet, now you can see it is related to all these various assets, if you will. One of them being the actual Ethereum address I was just playing around with. Also, another one is being myself as a user. So I, as a user, am allowed to see my wallet. No one else can see my wallet. And then diving one level deeper, you can actually see the asset itself. And so this is an example of that Ethereum address as an asset that we were just looking at. You'll notice that it's not actually related to a user. In Ethereum, everything is globally viewed. And so at the asset level, anyone can visit an asset. There's nothing inherently private about an asset that's on Ethereum, or an address is on Ethereum. And so in this particular case, we're just saying this particular asset is by virtue of its ID, is this address, and it's related to the Ethereum network. And that, once we do that, that is all the information that Cardstack needs to now start actually tracking this address and listening for events that are occurring on the blockchain, basically new block events. And then as those new blocks are mined, it will now look for transactions that occur that are either from that particular address or to that particular address. And so that, in a nutshell, is what's happening at that particular level. Do you want to go deeper into the code, or take a look at the code?
Yeah, take a look.
All right, great. So let's first should talk a little bit more about the Folio code here. And so the idea is that a lot of what the features you're seeing are actually native Cardstack features. Some of the features you're seeing are actually coming from the Folio app itself. And so if we take a look at, and also as another side note, we'll be open sourcing this shortly, so you'll be able to play with all this yourself. If you take a look at a Cardstack application, it looks, it is basically a monorepo. And it's a monorepo that is, we're leveraging Yarn to manage that monorepo. Within the monorepo, you see NPM modules for each of your different cards, as well as you see an NPM module for the application itself. For those of you that are familiar with Ember, this will probably look very familiar. You're actually looking at an Ember application, and these cards are actually Ember add-ons, which is Ember's way of actually having shareable, reusable modules. Within the Ember application itself, we have this folder called Cardstack, as well as if you look at each of the cards, there's a folder called Cardstack. So the way we're able to actually allow all this to work is that we have a place for all the front-end logic and a place for all the back-end logic. A card is really a vertical stab through all the different layers of application. So the idea is that it's all about creating useful places for you to. It's all about creating useful places for you to provide your data and provide your logic. And so the front end parts of the cards are all governed by standard Ember layout. The back end parts of the cards are all governed by this Cardstack folder and what are called features. And so the idea is that a feature is one of the many, could comprise of one of the many different types of plugins we have. So we have searcher features, we have indexer features, we have middleware features, we have authentication features. All these different types of features actually can help drive capability and help drive capability for your cards. In this particular case, so we're looking at the portfolio, and we have a bunch of different data sources. And so I'm just going to point a few of the interesting things out here. So we have an Ethereum data source, and the Ethereum data source is basically just saying this is where my geth node is. This is the particular content types that will hold fields that contain addresses that we want to track, and then it's just describing a little bit more about interesting computed properties that will be patched into these various Ethereum models that come out of the box when you npm install the Cardstack Hub. We also have a crypto compare data source. And the idea here is that we are actually caching crypto compare. So as we get exchange rates for all the different currencies for each day, what we do is we actually create a cache for that particular exchange rate so that we never ask for crypto compare for more than once for any particular exchange rate. So this allows us to incredibly efficiently use crypto compare's API, which basically means like we care about, I believe it's like three different exchange rates, or actually it's USD, euros, but then we have a bunch of different crypto exchange rates. But we're really only asking for each one of those once a day. And so this allows us to be really efficient with how we use crypto compare. And those particular exchange rates are then cached in the Cardstack's index. We also have a synthesized data source, and this is our asset history. And the asset history is where a bunch of different data sources actually come together. And so in this particular case, we have our Ethereum data source and our crypto compare data source coming together with our Git data source, which is also describing our tracked addresses. So if we go a little bit deeper into the specific cards themselves, let's take a look at the asset card. This is actually one of the more complex cards, but you'll probably remember the asset card had both the isolated view, which was the full screen view, and the embedded view. So we actually have templates for those particular cases. And so this is our template for the embedded view of the asset, and we also have a template for the isolated view of the asset. You may have recalled that when I switch between the even think about like what's actually happening there. And so like Ember Animate is actually picking out the interesting parts of each of these templates and then just animating them for us without us having to write any code to actually do that, which is really fast. It's really, really convenient. Going down into the actual Cardstack features, so what we see here is static models, a type of feature where we're able to describe the schema for a card. So these are all the different fields that comprise what an asset actually is. And so we have a bunch of different fields where we're saying we have like today's rates as a computed field. So that means that particular field is actually coming from the intersection of the information that's in Git as well as the information that's in crypto compare. So we actually have this folder called computed field types, and computeds are really the part of Cardstack where all the different data sources intersect. That's where the real interesting stuff is actually happening, where you can have the correlation between different data sources occurring. And so, so we have various computed fields that we define here as part of our schema. And then we have various grants. So these are the permissions that are available. Assets aren't too exciting in terms of grants. Basically, anyone can see an asset because, like I was saying before, assets aren't inherently private to a particular person because they're just available on the blockchain. So it's a really fascinating system. It allows you to integrate disparate data sources really quickly once you have established a schema that can describe your data source and then start relating these different types to different other data sources, external data sources. So that's a quick dive through our code. We'll probably be publishing guides as the weeks go on, so that people can get their hands dirty and like take apart one of these particular cards in great detail, and then describe how to actually assemble them. So with that, to turn it over to Chris.
All right, thank you. What's really cool about this application, the Cardfolio application, is that it's basically hello world for Cardstack. It's basically one of the simplest applications that actually leverage all the powers of Cardstack. For those of you who are not developers, the way I would describe the data system that we're using to assemble this stuff is Excel. Sheet 1 is all of your data from the external, copy and paste. Sheet 2 is some configuration data. Sheet 3 some like manual enter stuff. And Sheet 4 combines them all together to create that unified view. And as you know, in Excel, if you add a row, you change a number, everything auto updates. That's essentially what Cardstack does. We have taken that idea of propagation of changes in computation and formulas that are related, and then say, oh, what do I need to change and what cell has changed, and follow all that linkages. But instead of having you to download the file in CSV, it's actually continuous through our plugin system, listening to blockchain, listening to cloud APIs, interrogating Git repository, and all these things are kind of asynchronously propagating, as we call event sourcing, trying to find that truth among those things. That data infrastructure is probably more important than any of the UI that you probably say, hey, I've seen Etherscan, I've seen my Ether wallet, I've seen all these wallet. But what we have done is that you can now build on that. So if we go back to this kind of graph that we have about Cardfolio and Cardstack. So what we've shown is the Ethereum plugin showing ETH assets with a watch list and exchange rate and a portfolio with a user that logged in. Cool. But because of the composability of our system, now we can support Bitcoin and ERC20 assets with different plugins, different way of indexing, different way of working with the protocol as they exist, and then we can support different assets. We can now get the list of addresses, not just from Git, we can get it from a hosted wallet as a service. You can get it from your hardware wallet, something that's you own yourself. And then once you have that, then you can expand to the capability without ever really adding a whole lot more to the user. The user doesn't have to learn 10 more tools and log in to 16 more websites because this new ERC20 token or this other smart contract platform has their own Explorer, and you have to relearn those skills. We want them to choose Cardstack as the programming framework and this kind of pre-baked, easy bake kind of situation where they can just take the code that we have put together. Hassan has put together this kind of Cardfolio stuff, but there's also the framework that supports that allow this very simple JavaScript description, declaration schema to actually tap into a much deeper structure where we have a lot of automatic stuff going in for you, and we'll get into that in a second. So we see this as not just about building a portfolio system. We really believe this is a basis for a product suite that we can collaborate as a community and work it all together. So starting with this 5 cards, we can use that as the foundation to build an open decentralized finance suite, also a DeFi suite, right? So it's built on Cardstack Framework, share a lot of the plugin capability that we already built. It's open core, so all the core code that does all this introspection and ingestion and indexing and stuff like that, it's all built in. And then the plugins, which could be mostly public, we want people to integrate more wallet support, look at more devices that are hardware security key, deal with hardware security module in the cloud, and integrate all the API. But if you want to say, hey, I have a particular module that taps into my data source that only my team's going to do, you can sort of have a private module that in your installation of ODFS, you can go and run that. And the part that's live and staging right now will be live for the community to play with on Card.space, which is our kind of kitchen sink playpen for Cardstack application. But what you can see here is that we can go beyond just dealing with this static view of looking at the Explorer, wallets, and portfolio tracker, and going into workflow. I want to send $1 million worth of Bitcoin. Maybe the person helping you store the wallet say, hey, that seems like a lot of value. Why don't we go through a multi-sig process? Let's do some identity verification. Let's go through a workflow and have that. Let's say you want to say, hey, I want to actually perform an action and trade this. We can use this ODFS suite to say your card is now carrying the information and configuration to Git JSON to a trading firm that's taking that information as input without any transcription, stuff like that. So this idea of workflow, checklist, workflow, approval, trading, rate can be added on in the same compositional aspect that allows Cardstack, Cardflow to kind of satisfy 3 or 4 different categories of crypto application. And now it becomes like, okay, this is a lot of stuff. It's becoming more like a real application suite. And that's really the power of Cardstack. It's not really our beginning maybe as modest as everybody building an app. But application developer know this. Like if you're just building something to work, you can make it work, and then it gets harder and harder because your foundation not strong, so you can only build 2 or 3 story high until the whole thing crumbling down. Cardstack is designed to build 100-story tall, and with a lot of services overlapping. And what we're showing is the beginning of that, and we feel very good about the architecture, building this Cardfolio and using that as a foundation for the decentralized finance suite. Seems like a good way to use as a gift to the community, and then engage a larger community to make sure we support Maker, support DAI, support other type of compound finance protocol within this open source card composition user interface. Okay, so I want people to remember that every ecosystem, whether it's a financial ecosystem, a media ecosystem, a software ecosystem, requires people to get on-ramp to it. They need to have a way to get into the network. Currently, the way to participate in a decentralized network requires a Trezor wallet, a MetaMask, or something like that. And that's a very flimsy and fuzzy way of having key management and desktop app and Electron app and Mac app and iOS app mixed together. We believe the node to on-ramp could be a website. It could be something that a website you run for yourself on your own cloud, or a website someone runs for you, or a website that runs on your computer where you own all the code. You run it on your Docker and you have your database on the same computer. And we want people to see Cardstack as that node. So we are a client to the blockchain, but a server to your application. So the application you're playing with, that web application with demos and the future perspective of that, that's just an app. Just that participate in the web. It's Web 3.0, but it's also Web 1.0. It has a URL. It has, a place, and there are URL that you can go and see reference information. But there might be different players that have these different nodes. So whether you're an institution, a consumer marketplace, you use Cardstack as your on-ramp, and through the Cardstack synthesis in the hub, you can then access all these objects in the Web 3.0 space. But inside a particular Cardstack node is a lot of what Hassan has talked about, is this idea of these plugins that taps into blockchain and cloud. And when data comes in from the blockchain, from the node, it gets, go through the blockchain node, we cache it, we notify another system, we update the database, that create a composite data model, and then it goes into a friendly API, and then your web app displays it, right? Most developers have no problem understanding how to do these things, right? The API and the read, and that makes a lot of sense. We use JSON API. But what's really tricky is that most application framework has trouble writing the things in the right place. Oh, I want to make some changes. Does that go into a blockchain? Does that go into my own data source? You need to route it to the right place. We have the infrastructure to say, oh, you're trying to modify something that will go to Ethereum network, or you're trying to modify something that will go into enterprise databases. And then when that comes out, we say, okay, what changes have we made? Let's synthesize and reflect or auto refresh and refresh information and have that pushed to the browser. That stuff is just very much unlike a lot of the web application framework that developers building web apps are familiar with. It requires a different way of thinking, and this architecture, this Cardstack node, is an insight that we had. It's like, for us to be able to allow the blockchain, the cloud, and people to come together, you have to build this infrastructure, but build in a plugin way. But once we have these layers, the event sourcing, data model, and REST API, and to be able to use Docker to support plugin and NPM to distribute these on-ramp, I think that we've demonstrated the value of this Cardstack node, so that when you build ecosystem, and this could be one or more ecosystem, you can choose Cardstack as your your standard app server to go and skip over the 75% of the work that would just get to the point that Cardstack got into, but start working on like the Folio code, which is start declaring your object, declaring your template, and then getting to a point you can ship really nicely. So that's kind of what we want to update you guys. Our slogan is Experience Web 3.0, and so hope this demo showed you a little bit glimpse of that. It always seems a little ironic that with all the work that's gone to Cardstack, we can't really show. We have some internal test application, but it's really hard to show what's actually going on in this Web 3.0 world. But I think Folio will be a great way, or the Open Decentralized Finance Suite will be a great way for us to continue to demonstrate the capability of the Cardstack framework in a way that's concrete to users. This is very early in the application phase of the Cardstack infrastructure, and we're going to have a lot more thing. We're going to have people focus on creating tutorial and demos and new application to play with. But as a way to demonstrate the capability of the framework, the hub, all that plugins, we feel really good about that. That's like months, if not years of work that accumulated in being able to do this stuff. Obviously baby steps, one step in a way to get to that progress. But Web 3.0 is one of those things that will be built by the community. It's not going to be built by our team or the team in cryptos and stuff like that. What we want to do is to have people sharing the same tools, sharing the same practices. We belong to the open source community. We use open source tools like Node and Ember and stuff like that, and JavaScript as an ecosystem and ES6 and stuff like that. So we are part of that community. And certainly we're part of crypto. We know how challenging it is to build for Ethereum. And hopefully with this type of layers and these type of developer ergonomics that come with building these abstraction, we can accelerate our progress so we can see Web 3.0 much sooner than another lifetime. Meanwhile, everybody is trying to figure out, is Facebook and Google and Amazon all we're going to see? Are they going to buy every tech company on the sun and just centralize? The quest of providing a decentralized alternative to the centralized superpower is more urgent and more important than ever. And hopefully today and as we move forward, we're taking one step closer to providing that alternative. Thank you very much for your attention today. We will do this more often now that we have all this nice setup. So we will come to you with more updates and more fresh stuff and engage you in helping us get there. Your feedback and your questions and your comments are what's going to help us understand how to do this in a way that's not only technically correct and product-wise awesome, but also relevant to the fight that we're fighting together. So thank you and have a good day. Guys. Bye.
Bye.